extended reality, VR, virtual reality, AR, augmented reality, MR, mixed reality, and motion analysis for spatial navigation and tele-mentoring in HBP surgery. HBP surgery requires a high degree of spatial awareness and orientation because of complex anatomies and surgical procedures. Surgical navigation have become essential tools that enable for surgeons to perform complex HBP operations accurately and safely. The traditional surgical navigation was displayed only for two-dimensional observation by surgeons. The image-based navigation interface is separated from the operating area, and the surgeon needs to switch the field of vision between the screen and the patient lesion area. We developed extended reality navigation that combines virtual reality, augmented reality, and mixed reality and holographic technology for HBP surgery to provide more spatial and intuitive information to surgeons. From patients' individual CT images, organs and abnormal lesions were extracted into individually colored 3D polygons. We represented into VR space and real space using our original web-based XR application and wearable headsets. We have developed a commercially available cloud service Class 2 medical device certification in Japan that accomplished this within 10 minutes. We used HoloLens 2 headset. This has spatial CD camera and RGB camera and depth sensor and see-through display. See-through MR glasses allows you to see a real world with the virtual data of the patient organs. By using the gesture control, you can manipulate and move the patient using the Wi-Fi. You can share the local area of a position of the patient data and headset, and you can share the virtual environment in the air. Allowing the gaze and the user's attention to the holograms with a directional indicator reveals the user's intent. This patient have a atypical branching of IHPD, individual post branch, for a laparoscopic cholecystectomy. In the air, the surgeons can check the atypical anatomy of the patient during the surgery. The cystic duct is the spiral formed in acute cholecystitis. For liver surgery, every surgeon can check the location of the tumors and veins and the portal vein using the mixed reality headset. In Kagoshima University, the pancreatic tail cancer was removed laparoscopically using the hologram. They can check the surgical margin on the pancreas between the two monitors of the laparoscopic images. In Teikyo University, they removed the pancreatic tail cancer using Da Vinci. They can check the surgical margin of the main pancreatic duct and anatomical system of the individual patient using the hologram during the surgery. And the robotic surgeon can manipulate the patient data with their hands, and they can check the surgical procedure. For educational purposes, we are using the virtual session function. Multiple doctors wearing VR headset at the same time were displayed as avatars in VR space. They could discuss and browse the 3D organs in the air while freely moving around in the 3D space. This becomes a real-time interactive online conference, and it becomes a training that allows you to pass on interactive experience as they are. Now you can see the avatar in the air, even during the surgery. When we use VR, the ability to spatial awareness for understanding the extent of resection, blood vessel processing, lymph node dissection, and suture were improved before and after surgery. The motion of the surgeon's hand and head while viewing the VR were recorded in time series in the VR space using a motion capture sensor. Later, when another surgeon experienced this VR simulation, it was useful for training because it was possible to retrace the eye gaze and the technique using forceps at the same time tracing in the same series. In AR and MR, before and during surgery, each organ was floated in the real space with a transparent holographic wearable glasses with a position sensor, HoloLens, or magic leap. It was able to move freely in all directions, and the three-dimensional organ hologram and procedure could be confirmed with pointing. XR could help complex surgical procedures including dissection, suturing, and hemostat. The total operation time and discussion time were decreased. This has illustrative benefits in surgical planning, simulation, and education. The spatial surgical image-guided simulation provided better anatomical reference tool as a tailor-made guidance in HBP surgeries, and contributes to medical safety and accuracy, less invasiveness, and improvement of the medical education. This was also useful for recording surgical procedures in VR and for handing down surgical skills to the next generation. Conclusions. XR surgical simulation based on patient-specific CD and online remote VR conference improve spatial recognition. They are useful for overcoming limitations of virtual field and forceps movement of endoscopic and robotic HBP surgery.